Last time in our video, we discussed how does a battery work. And we talked about reduction potential or electrode potential. I want to go a little bit deeper into this topic about reduction potential. So what is a reduction potential? The tendency of a cation, for example zinc 2 plus, to accept electron. We know that gaining electron is reduction, right? The tendency of zinc an ion, cation, to accept electron to become a neutral element, this tendency is called reduction potential, and it is measured in voltage. The more the positive the electrode potential, the more it has the tendency to accept electron, right? But the question is, how do we measure? How do we measure it? How do we know what is the tendency of the zinc 2 plus ion to accept electron? How do you know what is the tendency of copper 2 plus ion to accept electron? To measure it, we need a standard, right? For example, when you go to bazaar, a market, when you say give me a 1 kg rice, so when they measure 1 kg rice in they need to have a standard, right? So say this is a machine where I would measure the weight, right? In one case, in one side I'm gonna put the rice, and in another side I need to have a standard 1 kg weight here, right? So when this will be in the same height, balanced, then I will say, okay, I have now 1 kg rice. So here this weight acts as a balance, acts as a standard. Likewise, when you would try to measure zinc, the reduction potential of zinc, you need to have a standard, and that standard is called standard hydrogen electrode. So practically, if you ask me, sir, how I'm gonna practically do this, how I'm gonna find out the reduction potential of zinc 2 plus. Well, this is how you do it. You take zinc 2 plus ion, say zinc sulfate, right, and put 1 mole per dm cube concentration of zinc 2 plus ion, that means zinc sulfate, and make a solution. Now you keep here this. If it is zinc 2 plus, you need to keep here the zinc electrode, a metal, zinc metal. Dip it inside zinc sulfate or zinc 2 plus ion. Now connect it with a voltmeter and connect it with this. On the other side, you're gonna have a standard hydrogen electrode. So what is a standard hydrogen electrode? A standard hydrogen electrode has 1 mole per dm cube of H plus ion. You may ask, sir, how do I know that 1 mole per dm cube is present? Well, if you keep 1 mole per dm cube of hydrochloric acid, if you keep 1 mole of hydrochloric acid, 1 mole per dm cube hydrochloric acid is equivalent to 1 mole per dm cube H plus ion. So I can write 1 mole per dm cube H plus or HCl as a solution. Now, as the electrode, you would use a platinum metal, PET, and also, interestingly, you need to put the gaseous hydrogen in a In this way you're gonna have hydrogen gas. So hydrogen gas, you would supply hydrogen gas here, and the hydrogen gas is going to react with the hydrochloric acid or H plus ion, and you will see the reaction is happening. So here, remember, you need to supply the hydrogen gas, and also you need to have 1 mole per dm cube HCl. You need to have a platinum electrode, and most importantly, the temperature should be 25 degrees Celsius or 298 Kelvin. And another thing is the pressure of this hydrogen gas should be 1 atmosphere. Remember, this condition, if you apply that, this will constitute a standard hydrogen electrode. Now, why do I need that? Because this will help me to measure the electrode potential of zinc. So now you can tell me, sir, okay, how about copper? If I want to find out the electrode potential of copper 2+, how do I do that? Remember, these values are in the data booklet. Whatever you see in the data booklet, the zinc 2+ electrode potential value, copper 2+ electrode potential value, all these values, how do we find out? The same way that I'm showing you right here. That's how they measured it and give you in the data booklet. Now, if I want to do it with copper, how to do that? I will keep everything same as for hydrogen electrode because it is a standard. This is a standard. You don't change it, but you can change this part because you are now trying to find out the electrode potential of copper 2+. So I'm gonna put copper 2+, and here I'm gonna put copper. That's it. Another important thing, I need to put also a salt bridge here. This is salt bridge. I think it's now clear what is standard hydrogen electrode and what is how do we measure the electrode potential of a half of an electrode, a single electrode. This is how we actually do that. Another thing is, remember, the electrode potential for hydrogen is 0 because it acts as a standard. Okay, so when we connect this thing, whatever the voltmeter shows us, that's the value of standard electrode potential. That's how you practically do it. I hope it's clear now. See you in the next video, inshallah.